the knowledge of using language. The information modeling, so can we invent some information modeling to read the text? Currently, we just scan the text and extract some keywords, ranking the words or sentences, or transform the text into a word net. So this is a kind of a word level processing, language level processing. But can we invent a different information model, discard the information in text? So this is the idea. And generate some concepts, cyber concepts, and provided the concept of service. So now we generated some word level concepts. For example, Apple. For example, some police. So it's a word. So it's far from the human level concepts. Human level concept of Apple consists of physical features and social factors. So it's a rich, very rich. For example, color and weight, taste, and something, a lot of features. But just Apple, A-P-P-L-E, it cannot reflect. Computer just process as symbol. So you cannot answer. For example, I ask computer whether you are hungry or not. Computer cannot answer, provide a correct answer. But for human beings can answer correctly. So we need the information modeling. Generally, a cyber concept. Cyber concept should contain rich content about the concept. It consists of physical features. So with cyber concept, we can provide question answers and some other intelligent services. So this is figure illustrates my idea. For example, the rabbits. The word is rabbits, but actually the concept of rabbits is richer, much richer than the rabbits. Rabbit is just a reputation. We need a more internal structure to describe the concepts. If we construct this kind of concept, I call it a cyber concept, we can provide the concept level services and build a semantic image like a human mind. So the knowledge in computer is based on cyber concepts. The cyber concept, the basic element is not the words. It's a structure. It's much richer than words. So this is a proposition of transforming data. I use text as example. Transforming data to knowledge. I propose 3 systems. This is information modeling systems. Modeling the information. It consists of many models. For example, based on statistics. Some models based on some graphs. Some models based on, for example, word maps, cognitive maps, and productive models, because different models are suitable for processing particular types of data. So a lot of models. So and also the scanning of data, we need different models, different paradigms to scan. We can scan sequentially, or we can scan according, not sequentially, according to some, the regulations. And then generate the information, provide the information to cognitive system modeling. The cognitive system modeling consists of 2 parts. One is conscious. The other part is unconscious. Unconscious systems process some, just modeling the human mind. Human mind, there's a conscious mind and unconscious mind. So this part is just simulate the human mind processing the information and generate the concepts rules, relations, and provide knowledge system. Knowledge space modeling. Now, knowledge system modeling, there's some knowledge, prior knowledge, and evaluate the concepts, rules, and relations. If it's not correct, then reject the knowledge. If it's correct, then store the knowledge. And also provide rules to supervise execution of the information modeling systems. But the strategy actually is distinguish data, information, knowledge. We distinguish the text. We don't think text is information. For example, one of our paper is capture information by scanning the text. Only scanning information generated. So your static data does not generate any information. Only when you scan, and different direction of scanning generate different information. For example, a policeman arrest thief. Then you scan the reverse. The meaning is different. So that means you scan the text in different models. You can generate different meaning. So we need information models to scan the text to then. So this is an example of separate data and information and knowledge. And the next strategy is open to human. So the split system you need to operate with, they interact with human. And they will interact with each other and interact with other systems. So you enable for the internet. So you need to acquire some new models, input some new models. And coordinate different kinds of systems to gain combined power. This separation enables one system focus on doing one thing. So information system only focus on doing information processing, using models to process information. Knowledge system only focus on processing knowledge. And cognitive system only focus on processing generative knowledge. How to evaluate? The next question is, okay, you propose a system, this kind of a system, and map the data into knowledge. How to evaluate? How to evaluate? So evaluation, I think there's three criteria. One criteria is the ability of obtain knowledge. So you can test, use Turing test to do some evaluation. If we ask the system a question, it cannot answer. Then you input data, input one paper, for example, or 10 papers. Then it can answer the question. Then it can say the system learned some knowledge. Because it cannot answer before, but when you input data, the system can answer the problem, the question. Then we can say the system learned the knowledge from the data. The second criteria is the ability to use knowledge. So whether the system can propose the problems by scanning the data. If the system cannot propose any problems, but when we input data, the system can generate some problems, find some problems. Then we can say we can use the knowledge, use existing knowledge to find the problems in data. And also the third criteria is the ability to propose and solve the problem. The system can use knowledge to propose a problem, and you also use the knowledge to solve the problem. So the three criteria of the mapping. Okay, let me talk about some grid knowledge. How to discover? We have discussed about how to generate data knowledge, but now some knowledge are grid knowledge. For example, calculus knowledge about the law of planet motion. This is solar systems. Brown, the supervisor, collect a lot of data about by observing the solar systems. After he died, Kepler analyzed the data and generated and proposed the law of planet motion. But my question is why his supervisor cannot propose the law, and Kepler can propose the law? Because my answer is because they have different motivation, different belief, different insight, different imagination. So data analysis, just mapping data from, establishing mapping from data to knowledge is about not about computing, just computing, about the motivation, belief, insight. Because the belief, okay, the motivation, Kepler's motivation is to discover the laws of the planet motion. But Brown's observation, the motivation is to purify the previous results, purify the previous data. There are some previous observations, but it's not very accurate. He wants to generate 10 times as accurate as the previous data. So he wants to measure the solar system more accurately. So the motivation is different. And also, Kepler's mind has some geometry concepts. He can describe the data by using mathematics. So, using the geometry concept to explain the law of motion. So when he proposed the law of planet motion, he would use the solution to verify his gravity, the law of gravity. So it's a kind of knowledge, is a kind of proposition, estimation, and verification, and use the new proposition to verify existing proposition. So great knowledge is not just in data, because different people can generate different knowledge. It's important data is very important. So the data should include, should implicate the law of planet motion. And also how to manage the knowledge and representation is very important. So when we talk about the belief, it's all about our cognitive systems. So the cognitive system includes motivation. A, there's a personal knowledge space and a representation knowledge. The human have the ability to represent external world. We represent and mapping the internal representation into knowledge space according to our aim and motivation. And also can interact with each other at the information level and knowledge level. And also when we can weaving, at the same time, we're weaving a theoretical network of reputations. So there's a big gap between the reputation, internal reputation in our mind, and external reputation. When we write, input into computer is called external reputation. There's a big gap, different. So when you ask some knowledge reputation. So when we use knowledge reputation method to represent our knowledge in mind, it's changed. So when readers read this knowledge reputation, his understanding is not different from my understanding. So it's a big gap between internal reputation and external reputation. And also, there's a big gap from symbol processing. Computer process reputation as a symbol, and human process internal as a knowledge. There's a big gap between symbol and knowledge. And human can understand internal reputation, know the meaning of reputation, but the machine don't know. Just process, you represent, just process a symbol. Don't know, don't understand. So this is difficulty of explaining and understanding reputations. And evaluating computing. It's very difficult to evaluate a model. So for example, there's a lot of model on document processing. Give me a paper. You can propose many models to describe the meaning of the text. But no one model can reflect the real meaning of the text. And it's very difficult to prove one model is better than the other. So maybe a lot of work has, is wrong. So we cannot expect to propose a best model based on the text. So to support the big data processing, we need a cycle infrastructure. The cycle infrastructure is because it is need human to design, maintain. And also, we hope it can extract knowledge from data, or mapping knowledge into data from data into knowledge. So we need to incorporate the cognitive systems. Actually, that work has been done in IBM cognitive environment. It's about how to combine cognitive development with computing development. Computing development very fast and can store a big data. But how to incorporate, combine cognitive development, human beings with the computing. So this is about the new infrastructure, not just about the information. This is information architecture, for example, how to deal with decentralized data storage, decentralized process. It's interactive semantic-based, multi-dimensional information space, or decentralized. This is about the information architecture. So how to incorporate cognitive modeling? There's a research area in cognitive science. It's about the cognitive architecture. So can we incorporate cognitive modeling architecture into an information architecture to form a cognitive cycling structure? And also we need to manage the community of cognition and practice. For example, big data is expanding, not just the computer science. The cognitive science almost many every areas in science are about big data. So this is about the science, engineer, users, communities. How to collect this data, manage this data, and enable them to interact with each other to provide a cognitive cycling structure. The cognitive is not just about the design of the architecture. It's about the user, and scientists, engineers, all the relevant human communities. So when we build this kind of interactive computer system, a lot of interactions within this environment. For example, scientists publish papers. Papers cite each other. It's citation, paper space, citation. And there are some comments. Online, you can find many comments. Comments about the paper. And also the data. So and also scientists interact with each other. We read, we write, we cite each other. So actually it's a evolving environment about data, concepts, motivation, thinking, knowledge, interaction. And also there are some hidden links. There recently a very interesting result that reject paper. When you revise it and finally get published, you get high citation. So there are a lot of implicit links. So my final part of this talk is about the nature of big data computing. So Turing machine is about all of our computers is based on Turing machine. My point of view is that big data brings a new paradigm of computing. it want to go to beyond Turing machine. The basic problem is to formulate problem about data. For example, sometimes we don't realize the problems. In many cases, for example, economic crisis, nobody can estimate economic crisis. If I can estimate the trend of stock market, nobody can estimate it. If I can estimate, I can earn a lot of money. So the problem is how to formulate problems, not solve the problems. Turing machine is about solve problem. Human find problem and then write programs and add computer to solve the problems. The big data provide an opportunity for people, for computing to find the problems and provide the answer, provide the solution, and recommend people. Because there are many cases we don't realize the problem. So big data provide an opportunity. So this is a computing world. The problem can be formulated. We can design the problem. We can define well-defined problem. We find a solution. And there's an uncomputed world. For example, some unconscious, unaware. We don't know the problem. How to define the problem? For example, economic crisis, we don't know, and unclear. And some unsensed world. Big data actually provide a chance to computing in this uncomputable world. So in future, there will be a traditional computing and big data computing cooperate with each other. So about the discover computing problems, so there are a lot of ways you can use to help computers to find problems in the big data. For example, we have a symbiosis in biology or in ecology area. So can we propose assumption about of an industry, establish an industry symbiosis? This assumption, and then we can see we can map see whether the impact of the industry. If we establish the industry symbiosis among enterprises, then we can see whether it has some good effect on the environment, and also we can propose some conjecture about establish the human-machine symbiosis, extend the symbiosis in the ecology area to computing area, and find the impact on the human-machine society by discovering and verifying some conjectures. So finally, I will discuss some limitations of big data. Because at the beginning, I mentioned big data is about reality and design and ability, capacity. So there's some limitation of big data. So how, for example, the first limitation is whether big data increase completeness. No. Whether big data lead to accuracy. No. Whether big data reflect rational thinking. Big data is different from thinking. No. Whether big data reflect richer semantics. No. Whether big data help understanding, because now paper on the web increased. But people still need time to read paper one by one, especially for research students. They need time to read carefully. No matter what big data, how the paper expanded, you still have 8 hours, 24 hours every day. So can big data solve hard problems? No. Can big data prove conjectures? No, because big data, for example, you can evaluate it. Okay? But for example, you cannot prove, for example, good dark conjecture. You cannot prove. So far, human can still cannot prove good boundary conjecture, but we can evaluate. We can enumerate. This is a page number. You can write continuously, but you cannot prove. So big data cannot prove conjecture. So all my talk today is about to look into the Plato's problem. Plato's philosopher, he proposed the problem of whether is there a correlation, causal or reciprocal relation between knowledge and experience. Experience is actually the data. Human experience everything, we collect data, but a human can generate knowledge from experience. But what is the correlation, causal or reciprocal relation between knowledge? No one can answer this problem. This is actually just inspiration, not solution. So this is the end of it.
We have time for questions. So we have a lot of this data, so the key thing is formulating the problem, right? Because we have to, because what is the problem? What do I want to get out of this data? So formulating the problems is much more important.
Well, more important, yeah, very important. Because in database, we can query, we search, query, it's no problem.
Yeah. So the question to ask in the data, so is there research in that area? How?
This is very
important.
And this problem is most database, big data area people, they don't aware of this problem. That's the key.
Yeah, what question to ask of the data? Nobody knows.
Right. So basically, what problem you want to face or to find out the problem, find out the unknown problem is difficult.
More difficult than find solution.
Exactly. Yeah, that's right. Yeah. I think for problem